Hello and welcome to my YouTube channel. Today in this video we are going to talk about the important parameters of an RTOS. Before starting to write any program or code for an RTOS, we should know what are the features of an RTOS, what are the limitations of an RTOS, and what are the other important parameters related to an RTOS. First of all, for any real-time operating system, one of the most important parameter is core timing and responsiveness. Then comes the second important parameter, the scheduling algorithms that are used by the real-time operating system. Third most important parameter is the resource management, and then comes the task management. And of course, reliability and robustness are very important for any real-time operating system. Apart from that, development and support that you can get from any particular RTOS is also an important parameter. So let us now look into these parameters one by one and try to understand why these parameters are so important. First of all, let us talk about core timing and responsiveness. Core timing and responsiveness is more or less related to the timing related parameters. For example, the first important parameter related to timing is determinism. This parameter is used to check whether the RTOS is able to perform operations in a predictable amount of time, because RTOS is all about real time. So determinism is one of the major parameter when we are analyzing the performance of any real-time operating system. Remember, real-time system must respond to events. When I say events, it may be switching of a switch or generation of alarm or any other event within a strict deadline. You should not miss any deadline in case of real-time operating systems. Variability, or we can say jitter, can lead to missed deadlines. Here deadline means there must be a specific time period within which the events must respond. If we miss that specific deadline, or if we miss that timeline, then we call it missing the deadlines. So determinism is all about the ability of RTOS to perform operation in a predictable amount of time. Then comes responsiveness. This measures how quickly the RTOS can react to any internal or external events like interrupts. Further, responsiveness can be measured in three different parameters. First one is interrupt latency. Here interrupt latency means the time delay between interrupt occurring and the start of corresponding interrupt service routine. For example, if suppose we have a function which is running F1, F2 and F3. Assume this is the sequence. So first F1 should run, then F2 and then F3. And in between that, suppose an interrupt generated. Okay. So interrupt has to be responded in the shortest time possible. But because F1 function is running, assume the microcontroller or RTOS takes some time, here delta t. Okay. So this delta t is nothing but the latency, or we can say interrupt latency. So it is the time delay between an interrupt occurring and start of corresponding interrupt service routine. Lower the latency, faster the reaction to events. We always try to make a system with minimum possible latency. Then comes context switch time. Here context means again events. Here it should be B. Context means events or tasks. So the time RTOS takes to switch from executing one task to another task is called context switch time. It should be again as low as possible. Faster context switching allows for better multitasking and quicker response to higher priority tasks. Then comes task scheduling latency. So here tasks are again we can call them functions or events, but practically the most legitimate term in RTOS is task. We will see what task means and how can we write different tasks. So task scheduling latency, the delay between the task becoming ready to run. So it is possible that a task may be ready, but it takes some time to run because another tasks are running prior to that. So that latency or that delay between a task becoming ready to run is called task scheduling latency. And of course jitter is one of the major issue or one of the major parameters related to core timing and responsiveness. Jitter is undesirable variation in the timing of periodic task events. What does that mean? It means, for example, if we have task T1 and sometimes it takes 1 milliseconds to rerun the task or complete the task T1 and sometimes 1.5 millisecond or maybe other time 0.95 millisecond. So this variation in the completion or response to any event is called jitter. We would like to have almost zero jitter or we can say minimum jitter as possible in any real-time operating system. Therefore, an RTOS aims to minimize jitter to ensure consistent and predictable behavior. So these are the parameters related to core timing and responsiveness. Now let us talk about operating systems resource management. So here resources are of course the parameters or peripherals which are there with the microcontroller or time. So first of all, memory footprint. We would like to design any real-time operating system kernel which should consume very less amount of memory, be it ROM, read-only memory, or RAM. So it is always better to write a RTOS kernel which takes least amount of memory from RAM or ROM. Second, scalability. It is the ability of any real-time operating system to function effectively and predictably across a range of system complexities. What does that mean? It means here the system complexity can be addressed as the amount of memory that you have, the amount of RAM that you have, or the amount of peripherals that you have within a microcontroller or microprocessor. Also, it also depends on how large you can make a real-time operating system, how many tasks, how many different events it can handle without any issue. So scalability is very important when it comes to resource management. And of course, resource management efficiency. How efficiently the RTOS manages the resources available with the CPU or microprocessor or microcontroller. So what are the resources available with the CPU? The CPU time, the memory, the peripherals. These are the integral parts of a CPU, and RTOS must be able to manage these resources efficiently so that it can meet all the tasks without missing any deadline and without any unnecessary overheads. Then comes memory allocation. So here the RTOS handles memory allocation and deallocation. How efficiently it can handle is very important when it comes to resource management. So if the RTOS can handle the memory or allocate and deallocate the memory properly, then we will call it a deterministic and efficient memory managed RTOS. Next comes the scheduling algorithms which are used by the RTOS. So there are many different scheduling algorithms which are used by different RTOS or different real-time operating systems. Some might be using priority-based preemptive scheduling algorithm. Of course, remember this is the most common algorithm which is used in all of the real-time operating systems. This is one of the most common scheduling algorithm, priority-based preemptive scheduling algorithm. In this case, this RTOS or RTOS which follows this scheduling algorithm always run the highest priority ready task first, and the highest priority task or higher priority task may preempt the lower priority tasks. So this is the most common scheduling algorithm used in RTOS. Then we can have a round robin scheduling algorithm where each task is provided equal CPU time in a rotating order. If you can recall musical chair kind of stuff, then in that case, here also the round robin scheduling allocates equal amount of time or CPU time to different tasks, and all the tasks get their turn in a cyclic order. Okay, because of that, switching takes place after a particular time slice. So all the tasks will get their turn after a scheduled time period. Then there is another scheduling algorithm known as rate monotonic scheduling. In this, after higher authority tasks or after higher priority tasks are run with shorter period fixed priority. So this algorithm assigns higher priority tasks with shorter periods fixed priorities. Then we have earliest deadline first scheduling algorithm in which the RTOS dynamically assigns priority to tasks closest to their deadline. So that means if suppose there are 3 or 4 tasks, task 1, 2, 3 and 4, and out of which task 1 requires 1 millisecond to complete its job, task 2 requires 0.5 millisecond. So let me write it. Task 1 requires 1 millisecond to complete its job. Task 2 requires 0.5 millisecond. Task 3 requires 3 millisecond, and task 4 requires 5 millisecond. So in this case, earliest deadline first will assign the CPU resources to task T2 first because it has the shortest time to complete its job, or we can say T2 task is closest to its deadline. Then after completion, T2 will be completing its job, then T1 will get the turn, then T3 will get the turn, and then last T4 will get the turn. So the priority is based on the task which has the closest deadline coming to its end. Last but not least, some of the most common scheduling algorithms used by many of the real-time operating systems is shortest job first, in which the RTOS runs the task with the shortest execution time first and minimizes the average wait time for all the tasks which are pending. We will go through these algorithms and see what are the benefits or trade-offs made when we choose one of these scheduling algorithms for our projects. Next comes the task management of RTOS. In this, it is checked how many number of tasks can the RTOS handle, or the maximum number of concurrent tasks the RTOS can manage. In this, some of the important parameters are the priority levels, how many distinct priority levels the RTOS can provide you. Different RTOS provides different level of priorities. Some may provide 5 different priority levels or 10 different priority levels, or some may give you 15 to 20 priority levels. And based on these priorities, the task with higher priorities will run first, and then the lower priorities will get their chance to use the CPU resources. Then based on scheduling algorithms, like I have explained in the previous slide. Then task management also deals with inter-task communication and synchronization. So suppose there are multiple tasks which require common resources of a system, maybe memory or maybe CPU time or maybe some peripherals. In that case, how the RTOS handle the communication between different tasks, it is also a very important parameter. So inter-task communication and synchronization covers mechanisms provided by RTOS for tasks to communicate and coordinate their actions safely. For it, RTOS uses many approaches like semaphores, mutexes, message queues, event flags, and so on. We will cover these terms or these functionalities as we move on with the course. Then comes preemption. This is very important term. Preemption is a term which is used by most of the real-time operating systems. So whether RTOS supports preemptive scheduling or not is very important. What preemption means? Preemption means when a higher task priority can interrupt a currently running low priority task. This is called preemption. So suppose there is a task running, okay, so we have a task T1 with a priority, assume 3, and there is task T2 which came when the task T1 is running, but its priority is P5. So because priority is higher, task T1 will be not allowed to continue, and task T2 will get all the CPU resources to run first. This is called preemption. If there is a facility of preemption, then this policy will be taking place in the RTOS. Otherwise, the lower priority task will keep running and the higher priority task will have to wait for the CPU resources. And there is another facility which is provided by the RTOS, which is called priority inversion handling. So suppose there is no preemption available with the RTOS, then tasks with lower priority will keep running even when the tasks with higher priorities are in wait state. So let us take the same example, task 1 priority 3 and task 2 priority 5. Even though the priority of task 2 is higher, if there is no preemption available, then task 1 will keep running and task 2 will be waiting. And this is called priority inversion. In this case, even the higher priority task behaves like a task with lower priority. So many RTOS provides this facility where we can handle the priority inversion related issues. Then one of the major feature of any RTOS is the reliability and robustness. Under this category, one of the major property that comes under this category is fault tolerance. It is the ability of any real-time operating system to work correctly even in the presence of some minor errors or faults. Then we have the ability of RTOS to handle errors, or we can call it error handling mechanisms. So in this, the RTOS should have mechanisms to detect, report and recover from potentially big errors or potentially harming errors which may cause instability in the system. Then comes last but not the least, safety and security features which are available with the RTOS. So many RTOS may have features of security and safety. For example, features like memory protection. So MPUs or memory protection units are not available with most of the microcontrollers. But RTOS may provide this feature where memory overflow, stack overflow, or memory mismanagement or allocation and deallocations are managed by the RTOS itself. Then it may have the feature to separate different hardwares and adhere to safety standards like ISO 26262 or IEC 61508. These are very important when we are handling with real-time operating systems. Of course, one of the major parameter to measure the quality of any RTOS is also the development and support that the user may get related to that RTOS. So, in this category, the ease of use and development tools which are available with the RTOS is very important, because in that case the user may get user-friendly APIs or functions, comprehensive documentation, reliable debugging tools with the RTOS, which will further improve the quality of systems that you generate and develop programs and systems with limited time and efforts. Portability. How you can deploy a RTOS program from one microcontroller to another microcontroller or from one system to another system is called portability. So if you are going to choose any RTOS, you should always check whether that RTOS supports portability or not, or how easily you can deploy your program from one processor to another processor. Then comes the vendor and community support. So you may encounter real-time operating systems where the vendor and community support is very less. So in such cases, you will have to design or write codes by your own, which may take very long time period, or maybe it will take lots of effort from your end to troubleshoot and maintain your systems. So avoid such real-time operating systems. Last but not the least, one of the major feature is the licensing and cost. How much you will have to spend to procure a real-time operating system is again a very important parameter. The way of licensing, whether it is perpetual or time limited or associated costs, can further increase the cost of your project. So always check about the licensing and cost of the RTOS. Then comes the middleware and libraries available with the RTOS. So middleware and libraries means, for example, if the RTOS provides you networking stacks, file systems, USB support, or many other parameters like LCDs, motor drivers, and so on. So does it provide you such APIs or middlewares to easily develop systems in the shortest time period? So you should always check all these parameters before opting an RTOS. With this, I would like to end this presentation. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you can get the notifications as soon as I upload a new video. If you have any suggestions or comments, then please share your comments and suggestions in the comment section. Thank you and have a nice day.